Good morning. Good morning, ladies and gentlemen. My name is Nguyễn Hoàng Khôi. I come from Busan National University, and today it's my honor to introduce with you our research on thermogravimetric analysis of the oxygen transfer capacity of ilmenite as an oxygen carrier in Oxy-Fuel combustion system. And my oral presentation has some parts as shown in this slide. And first of all, I would like to introduce to you the concept of Oxy-Fuel circulating fluid combustion and why we have carried out this research. And this is the schematic of circulating fluid combustion. And first of all, we use air as oxygen supply as the primary oxygen and secondary oxygen to residents. And is Oxy-Fuel circulating fluid combustion. We use pure oxygen instead of air, and we mix with flue gas, recycle and mix in mixing tank, and then we supply to as primary oxygen and secondary oxygen to combust solid fuel. So actually, oxygen carrier is a concept in chemical living combustion, and oxygen carrier material have a capacity to transport oxygen to combustor. So we adapted to apply oxygen carrier, and oxygen carrier is metal oxide, and metal oxide have the ability to transport oxygen, and so that's why we would like to apply oxygen carrier into our system. And another some advantages when we apply oxygen carrier is circulating fluid combustion system is that oxygen carrier will mix well in the combustor, so we advanced that improve combustion efficiency, and then we would like to reduce completed combustion. CO in flue gas will reduce the temperature in the cyclone. And the final purpose, we would like to consider about reduce poor oxygen from air separating units. So that's why we would like to apply oxygen carrier inside our Oxy-Fuel circulating fluid combustion. As actually, oxygen carrier is a concept in chemical living combustion. So we use this concept and apply to CFBC. And this is some behaviors of oxygen carrier in chemical living technology. And this behavior we use syngas and react with oxygen carrier. So we don't use this behavior, and we consider for solid fuel. And in solid fuel, oxygen carrier have two behaviors. First, shows gasification solid fuel first, and in this example we use coal. And first, coal will release volatile and char, and then oxygen carrier will react with volatile and some syngas from char. And another behaviors is oxygen carrier have a ability to release oxygen first, and then coal will release volatile and also char, and then oxygen from oxygen carrier will react with char and volatile. As in this study, we consider on ilmenite because ilmenite is a natural material and have enough oxygen transfer capacity. As actually ilmenite is well researched in chemical living combustion, so that's why we consider on this material and apply to our system. And this some rigorous study on ilmenite as the oxygen carrier is chemical living combustion, and also ilmenite is as bed material in CFBC. As this is the process of our study. First of all, we conduct some experiment in TA with the analysis reactivity of ilmenite as oxygen transport capacity of ilmenite, and then we apply to lab scale fluid bed to test behavior of ilmenite is lab scale, and then final step we apply is our pilot plant 0.1 megawatt of oxy CFPC. And this, let's move on to method and methods. We use the ilmenite from India with characteristic 75 to 300 micrometer and with this density. And actually, ilmenite have two states. First state is full oxidation. It's the full oxidation state, and the raw state of ilmenite. As some reaction we expected into thermogravimetric analysis. First for reduction, and the full oxidation state will reduce into this final state, and with some syngas. And for oxidation, just the final state and take up oxygen, and then to become a full oxidized state. And in this study, because we use some syngas like the hydrogen, CO, and methanation to test reactivity of ilmenite and also oxygen transport capacity of ilmenite. And some general results I would like to introduce is that the mass loss of ilmenite compared to other syngas, the hydrogen have a high capacity when reduce mass loss. Mass loss means oxygen transport capacity of ilmenite, and this is the test condition as SAM image. And as you can see, with hydrogen as reducing gas have a strong behavior is grain side of ilmenite, as hydrogen is the strongest reducing gas. And we use this equation to calculate oxygen transport capacity of oxygen carrier based on mass of full oxidation and full reduced. And this is summarized after some cycles. And as you can see, that hydrogen have can take up oxygen better than CO and methane. And this result we test with a different temperature, and we based on temperature in circulating fluid bed condition from 800 to 900 Celsius degree. And this result we test with from 800 to 875 and interval 25 Celsius degree. And as you can see, reduction of ilmenite proceeded faster at higher temperature, larger than 800 Celsius degree. As this slide, I will outline some kinetic model, volumetric, and string core, also three-dimensional diffusion. And we consider the obtained value of three-dimensional diffusion is with this energy activation and like this. And the summarize of effect of temperature as matrix we consider that actually the temperature did not much influence on the oxygen transport capacity at the temperature higher than 850 Celsius degree. And you can see that 3.5% and also 3.55%, and very low is 800 Celsius degree. As also the change in morphology does not appear to result in any noticeable effect on the oxygen transport capacity of ilmenite. So, effects of particle size. We select some range of particle size 75 to 125 micrometer, 125 to 200 micrometer, and also 200 micrometer to 300 micrometer, and test with oxygen barriers and reduction barriers. And as you can see, particle exceeded the highest reaction rate. And it is a CO2 concentration with different ratio of CO and CO2. Because in Oxy-Fuel combustion we use the flue gas recirculation, so we consider about effect of CO2 on behavior of ilmenite. And as you can see, without CO2, the oxygen transport capacity maybe gets over 5%. But when we consider with some different ratio of CO2 and zero, and we control oxygen transport capacity. As last, we consider preheating and raw state of ilmenite, and we consider how different. And as you can see, pre-treatment ilmenite have a good behavior than raw state of ilmenite. But however, raw ilmenite should consider as the first material for Oxy-Fuel combustion instead of pre-treatment ilmenite. As summary of oxygen transport capacity during some cycles, many cycles, it's 2 minutes for one cycle. Finally, in some conclusion, we would raw ilmenite show need to low reactivity and thus gradually increase, and oxygen transport capacity reached 2% with CO and methane and over 5% with hydrogen. Temperature and particle size did not have an impact to oxygen transport capacity, and increase the temperature, we increase glycine and also increase active iron element. And raw and retreatment ilmenite show the same weight loss, meaning the same oxygen transport capacity during any cycle. And oxygen transport capacity can be controlled by CO2 and CO ratio, and also we apply this model for kinetics research. Thank you so much.